Welcome to the Deep Dive. We're here to take a dense stack of sources, research papers, nutritional analysis, biochemical notes, and really to turn it all into immediate actionable understanding for you. And today, we're wading into a quiet but, well, a pretty fierce battle that's happening inside nearly every cell in your body.
It's a competition between omega-3 and omega-6 fatty acids.
Exactly.
And this deep dive, it goes far beyond just, checking the labels on cooking oils. We're looking at an enormous evolutionary mismatch.
An evolutionary mismatch. What do you mean by that?
Well, for millions of years, our bodies operated on a really balanced intake of these fats, but then modern industrialization came along and just completely flipped that balance.
And that's impacting the very signaling molecules that control things like inflammation, heart function, even our neurological health.
Right. And that's the core of the issue. These fats, they're not just passive energy sources.
No, they're dynamic, they're structural. They literally make up our cell membranes.
And they determine how fluid your cells are. Critically, they're the raw material for the body's entire command and control system for inflammation.
So before we jump into the crisis, let's just establish the ground rules. Why are these fats so special?
Okay, so both omega-3 and omega-6 are classified as essential fatty acids, EFAs. The reason is actually pretty simple. Your body lacks the metabolic machinery, specifically some key desaturase enzymes, to create them from scratch.
So we can't make it.
We can't make their parent compounds, no. That's linoleic acid, or LA, for omega-6s, and alpha-linolenic acid, ALA, for omega-3s. If we don't eat them, we just don't have them, period.
So our mission today is clear. We're going to unpack this biochemical traffic jam caused by the modern imbalance. We'll trace that imbalance back to our plates and then connect the dots directly to the widespread chronic health issues that seem to stem from this perpetually overstimulated inflammatory system.
Okay, let's start with the basics. What makes them different? If you look at the molecule, it's all about where that first double bond is.
The omega number.
Right. Omega-3 means the first double bond is at the third carbon atom from the end. Omega-6, it's at the sixth. Think of it like a mailing address on a long molecule.
And that tiny difference dictates everything.
It dictates their final function, yeah. And the signaling molecules they can become.
And the sources are what dictates the fight. On the omega-6 side, the parent, linoleic acid LA, is everywhere. I mean, it's just unavoidable in the modern food system.
It's ubiquitous. It's in all those high-use industrial oils like soybean, corn, sunflower oil, and it's in abundance in many grains and, importantly, in grain-fed animal products.
Okay, so that's the omega-6 side.
Yeah.
What about the omega-3 parent, ALA?
ALA is found in, healthy plant sources, flaxseed, chia seeds, walnuts, some green leafy vegetables. But here's the key structural difference.
Okay.
While LA and ALA are the starting point, the 18 carbon precursors, they need to be converted. They have to become longer chains to have the strongest effects on your body.
And these are the ones we hear about constantly, right? The potent active derivatives.
Exactly. For omega-6, the main active player is arachidonic acid, or AA.
AA.
And while we can make it from LA, we also eat a lot of preformed AA directly from animal products, especially meat, eggs, and dairy from animals raised on grain-heavy diets.
And for omega-3?
For omega-3, we have icosapentaenoic acid, EPA, and docosahexaenoic acid, DHA.
EPA and DHA, the fish oils.
Primarily, yes. They're mainly found preformed in marine sources, fatty fish, krill, and microalgae.
Okay, let's unpack this. If we eat both ALA and LA from plants, how does the body decide which one gets converted into those powerful long-chain versions like AA, EPA, and DHA? This is where the competition happens.
It's a metabolic assembly line. It involves two primary steps: desaturation, where you add double bonds, and elongation, where you make the molecule longer.
Right.
The critical mechanism here is that both the omega-3 and the omega-6 pathways rely on the exact same pool of shared enzymes to do this.
So it's like we have two separate rivers, the omega-3 river and the omega-6 river, but they have to merge and pass through the same single really small dam.
That's a perfect analogy. The primary bottleneck is an enzyme called delta-6 desaturase, along with another one, delta-5 desaturase.
Again.
And while that delta-6 desaturase enzyme theoretically prefers the omega-3 substrate, ALA, That preference is, well, it's completely irrelevant in the modern human body.
And why is it irrelevant? Is it just because of sheer volume?
Precisely. The overwhelming, crushing abundance of LA in the modern diet, which we'll get to, but it's often 15 to 20 times more than ALA. It just saturates the enzyme pool.
So the dam gets clogged with omega-6.
Exactly. The enzyme is so busy processing LA into AA that it has almost no capacity left to process ALA into EPA and DHA. It's a total biochemical traffic jam.
Oh, wait, so if I try to rely only on plant sources, say a handful of flax seeds, to get my omega-3s, my body's ability to turn that into the active EPA and DHA is severely limited just because I had, some soybean oil dressing on my salad?
That is the reality for most people. The data on conversion efficiency is, well, it's pretty telling.
How bad is it?
In healthy young men, the conversion of plant-based ALA to active EPA is often only around 8%. And for the really vital brain fat, DHA, the conversion is frequently negligible. We're talking between 0 and 4%.
Wow. 0 to 4%. That's incredibly inefficient.
It is. But there is a fascinating adaptive exception here.
Oh.
Women of childbearing age show significantly enhanced efficiency. It's closer to 21% for EPA and 9% for DHA.
That's a huge jump.
It's a clear biological adaptation. It's designed to safeguard fetal and infant brain development, which just shows you how crucial DHA really is.
But the takeaway for most people is that if you're eating a standard Western diet high in omega-6, you just cannot rely on your body to make enough of those active, long-chain omega-3s from plants alone.
No, you can't. And this is why EPA and DHA should truly be viewed as conditionally essential nutrients. You need to consume them directly.
Which brings us directly to the profound historical shift that created this whole bottleneck in the first place.
Yes.
This is where the evolutionary context gets really compelling for me. If you look at the human genome, it hasn't changed meaningfully for about 10,000 years. We're running ancient software.
Designed for an ancestral environment.
Right. The Paleolithic or hunter-gatherer diet. That diet maintained an optimal omega-6 to omega-3 ratio of about 1 to 1, maybe 2 to 1. That was our biological default for optimal health.
And that balance was just completely shattered by the Industrial Revolution and everything that came after. Starting around 150 years ago, we saw the mass production of cheap, shelf-stable industrial vegetable oils.
Soybean, corn, sunflower, cottonseed.
All of them. All extremely high in linoleic acid. You couple that with the shift to feeding livestock grain instead of grass, and we fundamentally altered the lipid composition of the entire food supply. Everything from baked goods to meat.
And the result of that shift, we catapulted from that balanced ancestral 1-to-1 ratio
to a profoundly pro-inflammatory ratio that most people in the Western world consume today. We're talking a ratio of 15 to 1, sometimes as high as 20 to 1.
20 to 1. That's staggering.
It is. And if you compare that to the broad expert consensus, which suggests maintaining a ratio between 1 to 1 and maybe 4 to 1, you can see the scale of the disaster. Our bodies are just genetically unprepared for this environment.
It's like trying to run 21st century software on a computer built in the Stone Age. The system just breaks down.
And many of us argue that this fundamental breakdown is a major driver of the modern epidemic of non-communicable diseases. The mechanism connecting that imbalance to chronic disease lies in the signaling molecules they produce. They're called eicosanoids.
Eicosanoids.
They're potent, short-lived signaling compounds that act like little instant messengers, essentially starting or stopping the inflammatory process all over the body.
So when you have this massive overload of arachidonic acid, the omega-6 derivative,
it becomes the dominant precursor. It generates these really potent pro-inflammatory eicosanoids, things like the 2-series prostaglandins, PGE2, and 4-series leukotrienes.
And these are necessary sometimes, right?
Oh, absolutely. For acute healing, if you cut yourself, they rush in to start the repair. But when they are chronically overproduced because of a 20 to 1 diet, they create that constant systemic smoldering inflammation.
A smoldering inflammation. I like that description. So if the omega-6 derivatives are the ones starting the fire, how do the omega-3s, EPA, and DHA act as, the peacekeepers in the cleanup crew?
Well, they do two things at once. First, they compete for those same enzymes, and they produce eicosanoids that are either less potent or actively anti-inflammatory, like the 3-series prostaglandins.
Okay, so they dial it down.
But the truly revolutionary difference is that omega-3s are the precursors for something called specialized pro-resolving mediators, SPMs.
SPMs.
Yeah, these are molecules like resolvins, protectins, and maricins.
And that distinction is crucial. It's not just about blocking inflammation, it's actively resolving it.
Exactly. That's the key. SPMs don't just passively reduce the fire, they actively coordinate the cleanup phase. They enhance phagocytosis.
Which is what exactly?
It's the process of telling immune cells to literally eat up and clear out all the cellular debris, dead cells, and waste products. They promote tissue repair to restore complete homeostasis.
So when your ratio is 20-1, you have a huge fire-starting force, but a tiny resolution crew.
And the inflammation never truly resolves, it just keeps smoldering.
So let's connect this smoldering cellular inflammation to the real-world issues. We have to start with cardiovascular health. That's where a lot of this research began, right?
It is. The competition happens right inside the platelets, the cells responsible for clotting. Arachidonic acid gets converted into thromboxane A2, or TXA2.
TXA2.
And TXA2 is an extremely powerful aggregator and vasoconstrictor. It tells your blood vessels to constrict and your platelets to aggressively clump together, necessary to stop bleeding, but dangerous if you have plaque buildup.
Very dangerous. So where does EPA come in?
When you introduce EPA, it displaces that AA in the platelet membrane. The enzyme then converts the EPA into thromboxane A3, or TXA3.
And TXA3 is different.
Critically different. TXA3 is a biologically weak aggregator. So by shifting the balance toward TXA3, you effectively lower the body's overall thrombotic or clotting potential.
So it literally makes your blood slightly less sticky.
Yeah.
Which is exactly what we want to prevent heart attacks and stroke.
Absolutely. And beyond that, omega-3s have other strong cardioprotective effects. They're known to reduce serum triglycerides by a significant 25 to 30%.
Wow.
And they stabilize the heart's electrical systems, making the heart muscle less prone to chaotic rhythms like ventricular arrhythmias that can lead to sudden cardiac death.
That's a powerful direct benefit. Okay, let's shift gears to obesity and metabolic syndrome. How does the omega-6 overload specifically drive weight gain?
The link here often runs through the endocannabinoid system, the ECS.
Okay.
This is a crucial system that regulates mood, appetite, energy balance. And arachidonic acid, the omega-6 derivative, is the direct precursor for endocannabinoids like anandamide and 2-AG.
Those names sound familiar.
Yeah.
They relate to the cannabis receptors in our brain, right?
Exactly. When a high LA diet increases AA availability, you're creating an abundant substrate for these endocannabinoids. They then overstimulate the CB1 receptor.
And overstimulating that leads to what?
It's clinically linked to hyperphagia, that's persistent overeating, and it specifically promotes the body's increased capacity for fat storage. A high LA diet essentially creates a pro-fat storage environment.
And the omega-3s intervene how?
Well, they fight back by displacing the AA, which limits the substrate for those pro-fat storage signals. And there's more. Omega-3s are also linked to promoting the browning of white adipose tissue,
Turning regular fat into fat that burns energy.
turning standard fat cells into more metabolically active cells that burn energy, yes.
We also see this inflammatory link show up really strongly in endocrine disorders, polycystic ovary syndrome or PCOS, for example.
Yes, PCOS is characterized by a core triad of hormonal imbalances, insulin resistance, and chronic low-grade inflammation. And clinical trials are pretty clear on this.
What do they show?
Omega-3 supplementation, even at moderate doses of 1 to 4 grams a day, significantly improves the metabolic and hormonal profile of these patients. They help reduce pro-inflammatory cytokines like TNF-alpha and IL-6, which directly improves insulin sensitivity.
And it helps with the hormonal side, too.
It does. They can favorably alter androgen levels, reducing bioavailable testosterone and increasing what's called sex hormone-binding globulin, or SHBG.
Finally, we cannot forget the brain. I mean, DHA is basically brain food.
It is indispensable. DHA makes up a huge percentage of the phospholipids in our neuronal membranes and in the retina. It's absolutely vital for synaptic plasticity. That's how your brain learns and forms connections.
And it's especially important early in life.
The need is critical during the 3rd trimester of pregnancy and the first 2 years of life. We consistently see that a higher maternal omega-3 status correlates with improved cognitive performance and better socio-emotional development in children.
And for older adults who are concerned with cognitive decline.
Maintaining adequate omega-3 status is neuroprotective. DHA plays a crucial role in minimizing the accumulation of amyloid beta plaques, which are, a key hallmark of Alzheimer's pathology.
So it's a resilience factor.
It's a key resilience factor against age-related decline, absolutely.
Okay, so if the problem is basically excessive omega-6 intake choking out essential omega-3 functionality, What is the most strategic path forward for you, the listener?
The strategy has to be a dual attack. It's not one or the other. Step 1, severely reduce the influx of omega-6. Step 2, significantly increase the intake of preformed long-chain omega-3s.
And reducing omega-6 means focusing on those highly industrial oils high in linoleic acid, which are, well, they're hiding in almost all processed and restaurant food.
That is the hardest part. You have to look at the source ratios. Corn oil is nearly 46 to 1. Sunflower oil can exceed 100 to 1. Soybean oil is around 7 to 1, yet it accounts for most of the oil consumed in the U.S.
So what's the move?
Prioritizing healthy, balanced fats like olive oil or avocado oil, and just drastically cutting down on processed ingredients. It's non-negotiable for rebalancing.
And for increasing the good stuff, what should we prioritize?
The hierarchy is simple. Marine lipids provide the most bioavailable EPA and DHA. So fatty fish like salmon, sardines, mackerel, anchovies. That should be your top focus.
And if you're on a plant-based diet,
Algal oil is an excellent source of preformed DHA.
what about things like flax and chia?
Well, ALA sources flax, chia, walnuts. They're heart-healthy, they're necessary, but you have to remember the conversion limitation we talked about. They should not be your sole source of EPA and DHA if you suspect your internal system is struggling from a high omega-6 diet.
And even in animal products, the source matters.
Absolutely. The ratio changes based on what the animal was fed. Choosing pasture-raised or grass-fed sources for meat, milk, and eggs provides a substantially more favorable ratio.
For instance,
For instance, grass-fed butter might have a ratio closer to 3 to 1. That's a massive improvement over conventional.
and is there a target dose people should aim for?
For healthy adults, the global expert consensus is to aim for a minimum of 250 to 500 milligrams per day of combined EPA and DHA. Hitting that baseline is essential for shifting the body out of that pro-inflammatory state.
This has been a compelling look at how modern food processing has just thrown a wrench into our ancient, sophisticated anti-inflammatory machinery. And the goal, really, it's not to eliminate omega-6. It is essential after all, but it's to aggressively restore that ancestral ratio by limiting the massive modern influx of LA and ensuring we have enough EPA and DHA to actively resolve the inflammatory fire.
Right, not just start it. And if you consider how much of the global burden of modern chronic disease, from heart disease and stroke to metabolic syndrome and neurodegeneration, is fundamentally underpinned by this cellular smoldering inflammation.
The ratio disaster.
The ratio disaster. It raises a provocative question for the future. How might personalized nutritional recommendations based not just on what you eat, but on mapping your specific genetic conversion efficiency, how might that fundamentally change how public health treats chronic disease in the next decade?
So targeting the individual's metabolic bottleneck.
Exactly. That level of precision, it could be the key to finally turning the tide.